Hello, this video is going to be a focus on looking at the incidence of excise taxes with a focus on how you can use elasticity, the price elasticity of demand and the price elasticity of supply, to inform you about the incidence of the tax. That is, how much the price is going to go up for the demander versus how much the price received by the seller is going to go down. Because in all realistic cases, there are some theoretical cases where all the tax is going to be borne by the seller or all the tax will be borne or paid by the buyer. In the real world, elasticities are very rarely going to be either infinite or zero, and so you can look at those two elasticities. Now, first I'm going to go through a very quick, very brief review of an excise tax incidence kind of problem. I'm going to put a link in right here to my introductory video on the topic. I'm not going to spend a lot of time on that idea. But I'm going to run through these three bullet points. The first is the equilibrium is the same no matter who is taxed. It doesn't matter if you put a tax on the seller or a tax on the buyer. Whoever is more inelastic is going to pay more of the tax. So we'll demonstrate that. And then we're going to use this formula to where if we have the price elasticity of supply, call it eta here, and then epsilon here is the price elasticity of demand, then the change of price for consumers can be calculated using this little formula right here, and then you can figure out how much of the tax is going to be paid by the producers. So let's get going here. So let's suppose we have this supply function here, which is P equals 3 plus Q is the inverse supply. The supply function would be minus 3 plus P. And so here we have the y-intercept at 3 and the slope is 1. The demand curve for inverse demand is 12 minus 1 half Q. The demand is Q equals 24 minus 2P. So we're plotting the inverse demand function here since we have P on the y-axis and Q on the x-axis as usual. So let's demonstrate this idea number one, that it doesn't matter who is going to be taxed. The way to model a tax, let's start by assuming that the tax is on the producer. And to do that, you have to remember that this supply curve represents the marginal cost to the producer. And what we're going to do is we're going to add in a $3 tax. So let me type that here. So we're going to add in a $3 per unit tax. Not minus, equals. Okay, so we're going to put on a $3 per unit tax here on the producer to start with. What does that look like? Well, all you do is you add in the $3 to the y-intercept of the inverse demand function. Why? Well, again, the inverse demand function represents the marginal cost to produce each unit. And if you're going to add $3 in extra costs, a tax that the producer has to pay per unit, then all that's going to do is take that supply curve. Let me copy and paste it here, and it's going to shift it vertically straight up by 3 units. So let me color that, say, red, so that we can see what's going on there. And I'll try to make it a little shorter. Okay, so this represents the supply curve, including a $3 tax that the producer would have to pay. Now let's look at what this new equilibrium is going to tell us compared to the old equilibrium. First, let's identify and discuss what the old equilibrium looked like. The old equilibrium price here, the intersection of the original curves, was at $9. So price is $9 and quantity equaled 6 units. Okay? Now we're going to look at this new equilibrium. The new equilibrium, the price paid in the market for this product is going to be $10. So with the tax, the price is going to equal $10. And this is what I like to call the consumer price, because this is what the consumer will pay. It's the intersection of the old demand curve and the new supply curve. The consumer is going to pay $10, but then what's going to happen after the business receives that $10? Well, they're going to have to pay $3 of that to the government in the tax. And so the actual amount of money that the business is going to get to keep is $7. So $7 is actually going to go to the business. $3 per unit will go to the government. So that's our new equilibrium, and our new equilibrium, it's kind of like we have two equilibrium prices, 10 and 7, $3 less, which is the tax. And our equilibrium quantity looks like it's going to be 4 units here. Q equals 4. Now, that's if the business pays the tax. Consumers pay 10, the businesses keep 7, and the quantity bought and sold is going to be 4, this new equilibrium. Now, let's just see what happens real quickly here if we put the tax on the consumers. Now, how do you do that and why? Well, the demand curve here represents the most a consumer is willing to pay for each additional unit. And so for the first unit, this consumer would be willing to pay $11.50. The second unit, consumer is willing to pay $11. For the fourth unit, willing to pay $10. So if you know that in addition to paying for the product itself, you're also going to have to pay a tax, then what that's going to do is it's going to decrease your willingness to pay for the product. Not the total price, right? The total price will stay the same, but your willingness to pay the price is going to go down because you know you're going to have to go and pay this $3 per unit tax afterwards. So here's what happens. The demand curve, you can model this by saying, well, the demand curve is going to shift downward by 3 units. 1, 2, 3. So the new y-intercept would be, let me color that red, the new y-intercept would be 9, and so our demand curve, once consumers know they have to pay this tax, is going to be 9 minus 1/2 Q. But let's look at what the equilibrium is going to be with this tax. The equilibrium price consumers will pay is going to be 7. However, that's not really the full price that they have to pay. That's what they're going to pay to the business is going to be $7. Then they're going to have to turn around and add $1, $2, $3 that they're going to have to pay to the government in tax if the consumer is the one responsible for, say, mailing it or paying the tax here. So what we get is exactly the same result as we saw before. So let me bring this little blue bar over here. It's the same result no matter whether the business pays the tax or whether the consumer pays the tax. The equilibrium quantity is going to be 4. What the business ends up keeping is $7. And what the total price the consumer is going to be paying per unit is going to be $10, regardless of whether they have to mail in the tax or they just pay the business $10 and then the business mails in the tax. It's going to be the same result. So in practice, to figure out what the equilibrium is, it doesn't really matter which you move, whether you shift the demand curve or shift the supply curve. All you need to do is really figure out what that new equilibrium quantity is going to be here, and in this case it's 4. And then you can see those two prices that are going to be paid. The price for the consumers is going to be 10. The price the producer gets to keep, you can think about this as net revenue after they pay the tax, is going to be $7. So you can see those two prices right there, 10 and 7. Now, let's compare that to the original equilibrium price here of $9. How much does the price go up for the consumer? So we've covered item number 1 here. The equilibrium's the same. It doesn't matter who you tax. Now let's cover point number 2. Point number two is how much of this $3 tax is being paid by consumers and how much of this $3 tax is being paid by producers. Well, tax incidence is asking the question, who is affected and by how much? It's a $3 tax, and the way to break it down is to say this. The old equilibrium price consumers used to pay is $9. Now the price they have to pay is 10, so the incidence for consumers is $1. The price that the consumers pay is going up by $1. What's the incidence for the business? Well, the price the businesses used to get to keep was the whole $9, but now consumers are paying 10, but businesses only get to keep $3 less after the tax. So businesses are, it's like they're losing $2 in revenue per unit. So consumers are paying $1 more. So let me type that up over here. This is kind of the synopsis. Consumers pay $1 more, and producers keep $2 less. And that $1 and that $2 add up to be the $3 total of the tax. It's just the way it has to be. So you could say the consumers are paying $1 of the $3 of tax, and the producers are paying $2 per unit of this $3 tax. Now, item 2 here says whoever is more inelastic will pay more of the tax. So, how can you tell who's more inelastic? Well, now elasticity is not the same thing as slope. But when you have a straight line demand or straight line supply curve, the elasticity is going to be related to the slope. And here's the formula right here. It's the same formula for the price elasticity of demand or the price elasticity of supply. To get the elasticity, you take the price you're looking at over the quantity and multiply it times 1 over the slope. The slope of the demand curve here, if you look at the price elasticity of demand, or the slope of the supply curve, if you're looking at the price elasticity of supply. So let's calculate these elasticities real quickly, but let me just mention to you that it's clear which of these is going to be more elastic or inelastic, because the P and the Q that we're starting from is the same for both consumers and producers. It's that old equilibrium price right there and that old equilibrium quantity of $9.06 units. And so the only difference in the elasticity calculation between the supply elasticity and the demand elasticity with regards to price is going to be the slope of the demand curve or the slope of the supply curve. So let's calculate those two. So setting up the formula, it's going to be, here, let me just copy this down here real quickly. We're running out of real estate a little bit down here. So first, let's calculate the price elasticity of demand. And that's going to equal P over Q, which is 9 over 6. So 9 over 6 is 1.5. 9 over 6 is 1.5 times 1 over the slope of the demand curve. Well, the slope we're talking about is the slope as it's graphed here, with P on the y-axis and Q on the x-axis. It's actually the 1 over the slope of the inverse demand curve. But 1 over the slope of the inverse demand curve, 1 over minus 0.5, is going to be the slope in the actual demand equation, where Q is written as a function of P, and so it's going to be minus 2. So 1.5 times minus 2 equals minus 3 is going to be the price elasticity of demand. Now let's calculate the price elasticity of supply. We're going to have the same P over Q, which is 9 over 6, so equals 1.5 times the slope, 1 over the slope of the supply curve. Well, the slope of this supply curve, or inverse supply curve to be technical, is 1. And so the slope is 1 over 1. So 1.5 times 1 equals 1.5 is the price elasticity of supply. So who is more elastic here? And what we're talking about is how large is the absolute value? How responsive are consumers compared to how responsive to price are producers? And what we see here is that the consumers are twice as elastic because the absolute value here, minus 3, is twice as large in magnitude as the price elasticity of supply. So item 2 here says whoever is more inelastic, whoever has the lower absolute value, will pay more of the tax. So price elasticity of supply has the lower absolute value. They're more inelastic than the consumers. That's why they're paying $2 of the tax instead of the consumers paying only $1 of the tax. Now, item number 3. It's actually the relative magnitudes of the elasticities that tells you how, not just who pays more, but how much more the producers or the consumers will pay than the other one. And here, the basic idea of this formula here, we're going to use it here in just a second, but the basic idea of this formula is just to say, look, the here the price elasticity of demand is twice as large as the price elasticity of supply. And since it's twice as large, what's going to happen is the consumers are going to pay half as much of the tax. That's why we're seeing what we're seeing here. Consumers are paying 1/3 of the tax, or $1 of the tax. Producers are paying 2/3 of the tax, $2 of the tax. And that's because the consumers are twice as elastic as the producers. And that's what goes into using this formula here. So let's actually plug into this formula to see what it does. So what this formula does is calculates the change in price for the consumers, or the tax incidence for the consumers, and then you can assume that the rest is going to be the tax incidence for the producers. So let's just fill in the blanks here. So we have price elasticity of supply, 1.5, divided by 1.5 minus the price elasticity of supply, and so that's 1.5 minus a minus 3. 1.5 minus a minus 3. Don't mess up these minus signs. So 1.5 minus minus 3 is actually plus 3 times the change in the tax that we're talking about. And since we're talking about a $3 tax, that's the change in the tax. So $3. So let's simplify this. We have 1.5 divided by 4.5, because 1.5 minus minus 3 is 1.5 plus 3. So we have 4.5 times $3. And 1.5 over 4.5 is just 1/3 times $3 equals $1. So this equation gives us the same result that we got, and the reason why I went through it kind of backwards is to convince you that this formula really does work. Now, what's important here is that this formula works even if we don't have the exact equation for the price elasticity of demand, the equation for demand, the exact equation for supply for a particular product. What if we only know the price elasticity of demand and the price elasticity of supply? Well, what this formula allows us to do is to be able to predict, or at least approximately predict, what the incidence is going to be for consumers and what the incidence will be for producers for a certain size tax. We just plug in the two elasticities into this formula and how big the tax is, and presto, we can make that prediction. So I'm going to end this video here. If you have any questions, as always, please leave a comment or question in the comment section below, and I'll be happy to try to help answer it. I hope this video helps you understand the relationship between elasticities and tax incidence.